Hello everyone, welcome back to Astro J Channel. Today we are going to talk about the solar flares. Solar flares are explosive events on the sun that release a tremendous amount of energy in a short period. They are characterized by a sudden increase in brightness and can emit radiation across the electromagnetic spectrum, including radio waves, visible light, X-rays, and gamma rays. The energy released during a solar flare can be equivalent to millions of hydrogen bombs exploding simultaneously. The primary driver of solar flares is the sun's magnetic. The sun's surface is not static. It is composed of convective plasma that moves in complex ways. This motion generates magnetic fields that can become twisted and tangled due to differential rotation. The sun rotates faster at its equator than at its poles. Regions of intense magnetic activity on the sun's surface manifest as sunspots. These are cooler, darker areas where magnetic field lines are concentrated. The presence of sunspots indicates a higher likelihood of solar flares occurring. When magnetic field lines become stressed, they can break and reconnect in a different configuration. This process releases energy stored in the magnetic field, resulting in a solar flare. The reconnection can happen rapidly, leading to a sudden release of energy. Often, solar flares are associated with CMEs, which are large expulsions of plasma and magnetic field from the sun's corona. While not all flares produce CMEs, those that do can further enhance the effects on Earth. The impact of solar flares, a spacecraft during a flare. For high-altitude flights, the increased radiation can also be a concern. Solar flares contribute to space weather, which can affect satellite operations and communication systems. The energetic particles released during the flare can interact with Earth's magnetic field, leading to geomagnetic storms. These storms can disrupt satellite functions, GPS accuracy, and radio communications. The interaction of charged particles from solar flares with Earth's atmosphere can create stunning auroras. These natural light intense solar flares can induce electric currents and power lines, leading to fluctuations in voltage. This can result in transformer damage and widespread power outages. Utilities often monitor solar activity to prepare for potential impacts on the electrical grid. Satellites in orbit are vulnerable to the effects of solar flares. The radiation can interfere with onboard electronics, leading to malfunctions or degraded performance. Operators may temporarily shut down certain systems during significant solar events to protect them. Due to the potential impacts of solar flares, scientists actively monitor solar activity using various instruments, including solar observatories and satellites like the Solar Dynamics Observatory, SDO, and the Solar and Heliospheric Observatory, SOHO. These tools help predict solar flares and assess their potential effects on Earth. In summary, solar flares are powerful bursts of energy caused by the sun's magnetic activity. They can have significant effects on space weather, satellite operations, power grids, and even the safety of astronauts and high-altitude flights. Understanding these phenomena is crucial for mitigating their impacts and protecting technology and human activities related to space exploration and communication. Continuous research and monitoring efforts are essential to enhance our understanding of solar flares and improve our ability to predict and